All right, so now I'm going to do 2013, number 2, which is also a calculator active question. So make sure that you have your calculator with you and make sure that all the settings are where you want them to be. And here we go. All right, so this particular question, again, gives us a velocity function. And it discusses the velocity over this interval here. So, again, make sure you're changing your window to only look at that. And then it also gives us a point position. So that's a position point right there, which means we're probably going to have to do some integration at some point here. All right, so for part A, it wants to know all the values of t from 2 to 4 in which the speed of the particle is 2. So let's remind ourselves that speed is the absolute value of velocity. All right, so I'm going to graph the absolute value of velocity, and I want to figure out when is that equal to 2. So in my calculator, before I do anything else, I'm actually going to define it. So menu, actions, define. And this one is really ugly, so make sure that you are as accurate as possible when you're typing it in. So v of t is equal to -2 plus, in parentheses, t squared plus 3t, and oops, there's no plus, raised to the 6/5, and then make sure you go down back to the main line when typing in the minus t to the 3rd. Okay, you don't want to keep typing in the exponent spot. All right, so there's v of t. So now I'm going to graph v of t, but again, when I graph, I need to graph with respect to x. Okay, so here's our nothing. Let's try that again. All right, so we need to make sure that we are... Why is that happening? There we go. V of x. So the absolute value of v of x, which was stored as v of t, but when we graph it, we want to see the absolute value. All right, so now I'm also going to graph the constant of 2. So we want to know where the speed, the blue curve, is equal to 2, the red constant, aka the points of intersection. Now it looks like there's a ton of them, but this question only wants us to answer over the interval from 2 to 4. So I'm just going to make sure that I visually am only looking at those two numbers, between those two numbers. So here we go. So it looks like there's 2 places of intersection over that interval where the speed is equal to 2. So I'm going to analyze it. And that value of 3.1276 is between 2 and 4. I'm going to do it again. And there's the other one. So both of those values are between 2 and 4, so that means that they are both acceptable answers for this part. So at t equals 3.128, if you're going to round or truncate, make sure it's 3 decimal places. And at t equals 3.473. Now, for this question, really you just needed to state that speed was equal to the absolute value of velocity and that you were looking for where it was equal to 2. You don't have to show the graph. You just need to let the reader know that you understand that the absolute value of velocity is speed. All right, part B. Write an expression involving an integral that gives the position s of t, and then using that expression, find the position at t equals 5. Okay, so we're going to be using an integral. So we know we're going to have to integrate velocity to get back position. Now, let's not forget this initial point right here. So we know a value, and when we know that value, we put it on the bottom, and we want to function in terms of t, so I'm going to make the t up there. And now when I write the velocity, I need to write it in a different variable. It's almost like a dummy variable. So I'm going to I use x right there. So that means if I integrate velocity from 0 to t, I would get back my position, which they're actually using an s here instead of an x. So I'm going to get back position at t minus position at 0. Now this question is specific. It wants to know what the expression is for s of t, which means now I need to isolate s of t. So when I isolate s of t, that means I'm just going to add this s of 0 to the other side, which means s of t is equal to s sub 0 plus the integral from 0 to t of v of x with respect to x. So make sure that the variables there don't match. Make sure the upper limit of integration and the input variable are two different variables. And whatever the input function is of the function, you want that to be your upper limit of integration. All right, part C. Find all times t in the interval from 0 to 5. So now they're changing the interval on us, so make sure we change our window, at which the particle changes direction. So a particle changes direction when its velocity changes sign. So we need to go back and we need to just graph. I'm actually going to go into a different window or a different page and graph just velocity, not speed. So I'm going to graph, or I'm going to attempt to graph v of x. I'm going to change my window now to be from 0 to 5. From window settings. Okay, from 0 to 5. And it looks like there's two places where velocity changes direction because there's two places where the function crosses the x-axis. So I'm going to find those two by looking at the, not intersection, at zeros. Menu, analyze, 0. Okay, there's one. And there's the other. All right, so I'm going to go back to my page and I'm going to write at t equals 0.536 and t equals 3.318. The particle changes direction. Oops, sorry. Since that is where the velocity changes sign. All right, so that is part C, and now last but not least, part D. Part D is the speed increasing or decreasing. So that's another way of saying speeding up or slowing down. So just like in the last question, in order to determine if a particle is speeding up or slowing down, you need to analyze the velocity at that point, at that time, as well as the acceleration at that time. So the velocity at 4 we need to look at, as well as the acceleration at 4. And we need to determine whether the signs are the same or if they are opposite. So we have v stored. So let's go back here. So we need to figure out what is v at 4. And okay, so v at 4 is negative. And now I'm going to find the acceleration. The acceleration is the derivative of velocity. So with respect to t, since we stored v of t earlier. And again, we don't care what the expression is for the acceleration. We want to know what the value is at a specific time. So we're evaluating it at t equals 4. Doesn't that look pretty? All right. So now we have a negative acceleration. So unlike in the last problem, we actually have signs that are the same. So v at 4 was negative 11.4758. And A at 4 was negative 22.2957. So this is less than 0, and this is also less than 0. So therefore, because signs are the same, it's going to be speeding up. So the answer here is speeding up because the acceleration at 4 and the velocity of 4 have the same sign. And there you go. There you have it. Just about 10 minutes as well. So 10 minutes, you know, these questions, the more you do, the more scripted they become, and you kind of know what to expect. All right. I'm going to end this one here and start a new one.